In this particular video, I am going to show you how AI can make job search smarter. In this particular video, I am going to show you three different ways to do the search. One is the exact search, semantic search, and the hybrid search. For this, let's get started with the demo. For this demo, I have created the job search application. Here I'll show you exactly what is the difference between exact search, semantic search, and hybrid search. In this particular dataset which I have stored in Weaviate, I have few jobs on QA. I'll search QA with the exact search. So it will give me the four results where we have the QA tester, QA senior software QA testers. These are the few jobs I have in my data store. If I'll search the QA automation, I can see even though I have a data in my database, there is no job found. This happens with the exact search. In exact search, you need to have both exact terms in your database so that it can be matched. To solve this problem, there is another thing which is known as the semantic search. In semantic search, instead of just looking into the keywords, it will try to see the meaning of that. So now if I'll search this, I can see even the automation engineer is coming inside these particular jobs application, because semantic meaning between the QA automation and test is similar. Another thing which we can do is do the hybrid search, which is taking the advantage of both the worlds. It will combine both the keyword search as well as the semantic search. So now if I'll search this, it will give me the jobs for the automation test engineer also, and if there are some keywords also, exact keywords, it will provide the weight to that too. So this is the example which I have created with the Weaviate database. In this video, I am going to tell you exactly how to create this particular portal and deploy everything in the local. All the stack which is used in this particular demo is the local stack, all the embeddings which we have created, and even the database is stored in the local. So without further ado, let's understand how to implement it ourselves. To actually empower this particular demo, we have used few technologies. For database, we have used Weaviate, and Python we have used as a backend language, and Streamlit for creating the UI, and Olama we have created for generating all the vectors. So this is going to be little big video. So they are in this particular demo, I'm going to have this particular flow. I'll show you how from where I have sourced the data, and how I have cleaned and sampled the data, then setting up the local Weaviate and data ingested in Weaviate, how to fetch the data, and the Streamlit UI. So feel free to move to any particular chapter if you feels like that is not useful for you. At the end of this particular video, the aim is to understand the complete data ingestion and data retrieval flow for the Weaviate. So as the first step, I'll do the data sourcing. For data sourcing, I have used this particular dataset, job description dataset from Kaggle website. And this particular dataset has around 23 columns. And if I have downloaded this dataset after uncompressing it, its size is around 1.5 GB, which is a huge size. So for our demo, I have to clean the data and sample the data. For doing so, I have written a Python script, which I'll show you. So in this particular script, I have loaded this particular data set, that is job description.csv, and out of the 23 columns, I have kept the column like job ID, job title, company, location, skills, job description, and responsibilities. The other columns are not that relevant for this particular demo, so I have dropped it. I have created one more column, that is the search text. For search text, I have combined the job title, job description, skills, and responsibilities. There are two approach actually to make the vector search. One is to make all the columns as the vector itself, but that won't give that much good result, as each column will have its independent vector. Another approach is to combine all of these particular columns which are relevant for vector search and make a single column. I have created a search text for that. And after doing all these things, I have only taken the 300 data set and created a random sampling out of it and saved it into dataset job dataset demo.csv. So after doing all this cleaning, our dataset, I'll show you how exactly that looks like. After cleaning our dataset looks like this, which contains job ID, job title, company, location, skills, job description, and responsibility. We have another extra column, that is search text, which we have kept for the vector search. Like the sampling which we have done, with which we get exactly 300 columns here. Once we have sourced the data and sampled the data, the other part is actually to set up the Weaviate local setup. For this, I'll show you how to create the Weaviate local setup with Docker, and we'll do end-to-end setup in our local in Docker. For doing the local setup, you can go through the Weaviate quick start guide. It has all the steps that is required for the local setup. So for that, you have to install the Docker in your local and Olama. So Olama, you need it for generating the vectors, and this setup is actually for RAG setup also, where you will be needing Llama 3.0 for the generation, but for this demo that is not needed. Then for the setting up, you can create for creating the setting up the database, you can use the Docker Compose. You can use exactly the same Docker which you have here, Docker Compose file, and you can copy paste in your local and run the Docker Compose up command. So I'll show you, like in my local, I have this Docker Compose. I have started this particular Docker Compose with Docker Compose up. I have Podman instead of Docker in my local. So in my Podman desktop, you can see there is one particular pod that has started, that is for the Weaviate. So Weaviate 1.3.2 is running in my local. So once you have started your database is running in the Docker, the second thing is about installing the library that will check in the code. Once this particular database is running, the next part is to create a collection. So for creating that, I have actually used the curl. I'll show you that particular exact curl which we have. So this is the curl which I have used to make it little beautiful. I'll just open this in open preview. So this is the curl which we have. So in this particular curl, we are creating the schema. We are creating one particular class using the vector. We have the few columns. I think that looks better even than that, because that we need to understand the JSON. So we have the module config, where we are configuring what particular model which we wanted to use for creating the embeddings. Then we have all of these properties where we have set this skip as a true. And the last property which we have, text search, which we haven't skip at for vectorize. That means only for this particular column, our vector will be created. So I've tried this with curl and it is working fine for me. But when I tried with the Python client, it is somehow not honoring this particular skip thing. Like even though I'm creating the skip true, but in the schema it is taking it as false only. You can run this curl yourself, or you can go through Postman. So in the Postman, I have run this particular curl. So this is the curl I have. So when I run this, it will go and create the schema. For checking all the schema which are present in my database, I can again run this. So there are few other classes that are there, and I'll show you where exactly my this job posting schema is there. So this is the schema which we have as of now. So in this we have the properties. In properties, you can see the property name and whether the vectorize skip is false or true. So this is true. That means the vector won't be created for this particular column. Similarly, for all the columns, same thing will happen. and the only one column which we have, that is the search text. This search text where this skip is false, that means for this particular column we will be creating the vectors. So with this we have set up the local Weaviate in our local, and we have created the schema for the job posting where we are going to push the data now. For loading the data in Weaviate, I have written this small script which will connect to our local Weaviate database and create a client on base of that. We have a CSV file, job dataset demo, which we have created with the sampling. This particular file we will take, and on the basis of this particular file, we'll check the collection job posting is there or not. We'll get that, and we'll push the data in batches to Weaviate. We'll run this, we will be able to create all the job postings in our Weaviate database, which can be searchable for us. So I've already run this particular file also, script also. So if we'll go to our Weaviate database, and in the database we have the count API also. This is the API which we have for getting the number of counts in our database. So if I'll click this, I can see that the count is 300. So all the data which we have in that file is present in this particular collection. Similarly, Weaviate also provide one of the API where we can understand what all data we have. We can see the actual data. We have a job posting collection where we have job ID and job title. If we'll click on search, we can see the data, like which all jobs which we have in our database. So all the 300 jobs which I have shown you just now, we can see here from this particular call. So till this point of you have seen how to ingest the data. So now data is in database. The other thing which we have to do is do the searching on top of that particular database. So in the next section, we'll look into that. For fetching the data, I have created 4 APIs. First API is for the exact search, that is BM25. Another is for the semantic search, and the third one is for the hybrid search. Another is to get all the jobs. This one we have created just to get to show in the UI all the jobs without searching. And then we have an exact match. In this, we are searching on the basis of property like job ID, title, company, location, skills, and then we are filtering the data from our database on the basis of BM25. The another API which we have is for the semantic search. In the semantic search, we'll get the data, and we will be using the near text function from the Weaviate. This particular function will give us the semantic search result from our Weaviate database, and will return that. So here, because only one column which we have as the vector, that is the search text, so that will compare to that particular search text column and return us the data. The third API is for the hybrid search, where we'll combine the BM25 and the vector search. So it is like the best of both the worlds. So there is one parameter here, which is the alpha, which decides how much you wanted to give weight to the exact search like BM25 or to the vector search. Once we have these APIs ready, we can test it from our Postman directly. So for the exact search, this is the API which we have. I have already created this, like company. For the company Asian Paints, if I wanted to search and do the search, I'll get the data here. This is the exact search which we have. For semantic search, we can search the like software engineer remote. So it will understand the meaning of this, what we wanted to understand. On the basis of that, it will create a vector and try to search with the search text and give us the data. So if we'll search it, we can see the software engineer job titles. It will try to see all the job title, even though this particular keyword is not present, we will be getting the data if the meaning is somewhat similar. Hybrid search combines both of the approaches. If we'll search it, even though we are searching for data scientist Python, because in our database we have only the search analyst, we'll get that as the top thing. And this is for getting all the jobs which we have. So yeah, we'll get all the 300 columns which we have. We have the put the limit here, so we'll get the top 10. But it can we can retrieve all the 300 data which we have in our database with this particular API. So this is all the APIs which we have. Now on the basis of this API, the last part remaining is to create the UI. For UI, we have used the Streamlit, and Streamlit we are able to create the UI which I have shown you. So with the Streamlit, we can see like this is the UI which we got, and here we have the options to select which search we wanted to. Like I have shown in the demo, like we can search here QA engineer and it will give us the jobs which is actually having QA present in this particular job description. Similarly, for the semantic search, even if we'll search QA automation, we should be getting all the records here for something which is relating to testing. And similarly, we can we can use the hybrid search, and we can control this alpha on the basis of our use case. We wanted to get the more semantic meaning, we can reduce it to 0. And if we wanted to go more towards the keyword search, we can set the alpha towards 1. This is all for this particular demo. If you like this video, do leave a comment. This will help this channel to grow. Until next time, keep learning, keep building. Goodbye.